So I'm John Daniel M. Osmeña of Group 1, and I'm here to demonstrate and present to you the first problem in our Lab 5 activity or experiment. So first we are going to go to the Excel, and here I created two different tables, one for the vowel and consonant encoder, and one for the vowel and consonant decoder. So here I used my second name because my first name is John, so it only has one vowel, and all the three other letters are consonants. So it would be more appropriate if I used my second name, which is Daniel, which has three vowels and three consonants. So so here, as you can see here, this is our encoder truth table, our 6-bit encoder. So you can see here, uh, there's only one instance per letter, and we can see here like in the given instructions, uh, the resulting uh, the resulting output for the consonants are 111 or C. As you can see here, the resulting outputs are ones for the consonants, and for the vowels are zeros, 00 to um 011. So as you can see here, we have our first vowel, which is A, which is designated as with an output 000, and our vowel I, which is 001, and our vowel E, which is 010. If we had a fourth vowel, we would that would be designated as 011. So we can see here, we obtained the sum of products of these outputs with our output A. Our sum of products from our K-map is L ORed with N ORed with D. For B is L ORed with E ORed with N ORed with D. And for C is L ORed with I ORed with N ORed with D. So as we can see here, there is no there's no variable A here because A is this A's output is just all zeros for the three outputs. So I'll show you our implemented truth tables and K maps first for our encoder. So I have pre-placed some of our components so that it won't take much time in building. So for our encoder is our encoder. Let's just imagine that each each input here is a button or like this, and this is the equivalent for our encoder in our Excel. So we will now recreate this encoder to in our main circuit to make it function, and this here is our three inputs A, B, and C. So we can copy or paste this or recreate it, but let's try and recreate it. Let us first the output line, the lines for the letters A. Let's put a line for A for now so that uh, it's we are following it's a step by step process. We are following a step by step process. So, so here is our initial input lines. So now we are going to refer to the Excel. Can this camera. So first we will do our first output A. Let's just get the pin out here. First output A, and we will need a or IC. Flip it. Place it here. place it here. So we are going to place L first. L word with N, and then this output is and D. And this is the output A. And this place is here so that we have an organized. Let's do south placement and label this A. Put there. Just copy this 3 more times. Push the labels to A. And for our second output, L is then ORed with E. So we're ORed with E. Then N. And we're going to utilize another OR IC down here. Excuse me. Place it over here. Let me just reset the simulation. Enable it again. And we have done L, E, and N. So we need to place P, C. Oh, sorry, click the share it again. And this. Let's just reset the simulation and simulate it again. Fix our problem, and that's our output. Our output B, and we have our last output, output C. So let's start first at the top with an L. Over here, L and an I. So I just fix wiring a little bit. This one, just fix it a little. There you go. Then we will rotate this to the other side of the IC. Place it here. And we have our L and I. L or I. Now we need the N and D. N and D. And that is our output C. So we can test it. Let's clean this up first. As you can see, A is left unconnected. So if we test it, it should be, if D is given it's all ones, A is all zeros, as you can see, because it's not connected, and N is all ones, I is 001, E is 010, and L is all ones. So it's enough, it's in the correct format. Let's just maybe fix this a little, make it more compact. There we go. Now we are going to attach this three outputs to our setup here. But first, before I attach it, uh, just before I attach it, let us check the VC decoder table. So as you can see here, we have placed the outputs of the encoder here, because the outputs of the encoder will go to the decoder so that those outputs can be decoded into a 7 segment 1 digit display. So as we can see here, this 7 output is the 7 segments, and all the ones are all the ones and all the outputs are tailored so that each output will either output C or the vowels that are in the name, for example, A, I, or E. So for the first line, we have C because it's a consonant. And for the three vowels, we have here is an A, tailored for A. This will show an A. This is a 7 segment for an I, and this is a 7 segment for an E. So as you can see here, this is each of the uh, sum of products of the outputs from their key maps. So for 01, we have C prime and so on. So since we have similars, can show you from our decoder. Since we have similars, we have a lot of similars. A lot of them was just used, or we just joined here, like you can see for O2, output 2, output 3, and output 5. They're just similar C prime ORed with B. Disconnected, same with O7, O4, O7 and O4, and so on. So basically, these are 7-bit, 3-bit to 7-bit decoder. So here's our input line, and it only uses a NOT gate and an OR gate. I see. So applying it, this is our VC decoder. And now let's attach our outputs to our decoder. Just fix this. There we go. So as you can see, it outputs all zeros, it outputs an A, because all zeros means A. Even if we press here, all outputs are A because it's all zeros. If you made that a 001, then the initial output will be blank, will be a blank 1 digit 7 segment display. And for D, we have consonant C, or C for consonant. N, we have another consonant. I, as you can see, it displays an I. E, it displays an E. L, displays a C for a consonant. So if you look at here, the same, it outputs the given line. So for our 010, or the E, it outputs a line of 1110110. And for our I, it outputs a 000100 and 1. And for our consonant, it outputs 0110110. So that's all for problem 1 for the group 1. Again, I'm John Daniel Osmeña, and thank you for watching.